Good morning, guys. Today we're going to work on solving rational equations and inequalities. So the first thing we want to do is simplify it down. Think of it like a proportion. If I can get it into being a proportion, a fraction equals a fraction, it's real easy to solve. So that's the first thing we're going to do. We want to rewrite it, clean it up so that it looks like a proportion. A fraction equals a fraction. And then from there you cross multiply, solve like normal. Now because these have restrictions on their domain, much like the logarithmic equations we worked earlier in the year did, because rational equations and rational functions have restrictions on their domain, we've always got to check for extraneous solutions. Remember, extraneous solution is an answer that we get, and algebraically it works out, but if we plugged it back into our function, it would not fit the definition of that function. Remember, we couldn't take log of a negative, so if we had a solution that made our original function be log of a negative, we had to say it was extraneous. Well, in rational functions we can't divide by 0. So when we check for extraneous solutions, we're just plugging that back in to make sure none of our denominators come out to be 0 with that value in there. So let's go through an example. First thing we do is simplify each side so we get fraction equals fraction. Well, the right side's already a single fraction. It's ready to go. The left side, however, is not. It's a sum, or it's a difference of two fractions. So we're going to go through and combine those two together. Remember, using your subtraction rules of getting a common denominator. So this has an x for its denominator factor. This is x plus 1, so this needs an x. This needs an x plus 1. If you need a review on adding and subtracting rational expressions, go back and check that lecture out. So we get 4x plus 1 minus 3x all over our common denominator of x plus 1, still equal to 1 over there. Clean it all up. 4x minus 3x is x plus 4. We'll go ahead and write that out. I don't want to lose anybody there. So distribute 4x plus 4 minus 3x. For the denominator, we can distribute that out. X squared plus x, still equal to 1. Combine your like terms. X plus 4 over x squared plus x equals 1. And now we have a fraction equals a fraction. This is just that over 1. So we go through and it's a proportion. We cross multiply and solve like normal. So 1 times x minus 4 equals 1 times x squared plus x. And we solve our quadratic equation that we have here. X minus 4, x squared plus x. Subtract the x over, they cancel out. So we get x squared minus 4, plus 4. Come on, speak up. Plus 4. So if I have x squared plus 4, move it up here, x squared equals plus 4. How do we get x by itself? Take square root. So x equals plus or minus 2. So we've gone through, we got x equals plus or minus 2. We check it out. If I put in positive 2 right here, 4 divided by positive 2 is a number. We're good there. Put in positive 2 right here. 2 plus 1 is 3. Still not 0, so we're good. Check your negative 2. Negative 2 for a denominator is fine. Negative 2 plus 1 is negative 1. That's also fine. So as long as I plug these back into my denominators and none of the denominators equal 0, then our solutions are not extraneous. They work out. And you'd want to go back through and check them even further, just make sure you've solved correctly. But that's the idea behind solving rational equations. Give me a second and I'll get another one up here for you guys to try. Okay guys, here's the second example. Take a minute, pause the video, try to solve this, and I'll wait right here. Okay, hopefully you were able to get a solution. Let's see how you did. Two ways you can work this one. We'll go through the obvious way first, and I'll show you another way to look at it. So we have one fraction on the left, two fractions on the right, because 7 over 1 is a fraction. It's a rational number. So we're going to go through and get common denominators. This needs a factor of 1. This needs a factor of x minus 2. No, technically that doesn't need a factor of 1, but just so it looks balanced, it's a little bit easier for people to see that way. So we have 7x minus 2 plus 10 times 1 all over our common denominator of 1 times x minus 2 equals 5x over x minus 2. Clean up the right side by distributing 7x minus 14 plus 10 over x minus 2. So that's going to give us, what, 7x minus 4 over x minus 2. On the right side, 5x over x minus 2. So we now simplified it into a proportion. A fraction equals a fraction. So we're ready to cross multiply. So we'll do 5x and x minus 2 times x minus 2 equals x minus 2 times 7x minus 4. Okay. From there, distribute combine like terms. 5x squared minus 10x equals 7x squared minus 4x minus 14x plus 8. So we'll just distribute, combine like terms. Get everything to the same side. So let's move our 5x squared over, move our 10x over. So we have 2x squared, 14 is negative 18, plus 10 is negative 8. X plus 8 equals 0. And then we solve this quadratic. Everything can divide by 2. So make it a little bit smaller. That'll factor. X minus 2, x minus 2. So we go through, x minus 2 equals 0. So we get 2 twice. So we get x equals 2. Now if we go back and check, if I put a 2 right here, 2 minus 2 is 0. So it doesn't matter what anything else is. We're trying to take a number divided by 0. And we're actually doing it in 2 different places. So because 2 produces a 0 denominator, then we say it's extraneous. There's no solution on this one. Now, if I'd got 2 different answers and only one of them was extraneous, we'd just dump the extraneous and we'd keep the one that's not. But this one right here, we got 2 solutions and both of them came out to be extraneous. Now, a couple places I could have shortcut it. Right here, where I had 5x over x minus 2 and 7x minus 4 over x minus 2, since both denominators were equivalent, I could have jumped to just saying 5x is equal to 7x minus 4. So we could have done that there. If the denominators are equivalent, then the numerators are equivalent. So let's just solve the part that's different. So we could have said 5x equals 7x minus 4. So I could subtract 7x over at that point. So you get negative 2x equals negative 4. And divide by negative 2. So x is equal to 2. So we could have got our 2 that way. Another place where this one could have got a little cleaner for us is if at the very beginning we had noticed that these two have the same denominator. Instead of combining those together, we could have just subtracted the 10 over, the 10x over 2 over. So if we'd have done 5x over x minus 2, subtract that 10, x minus 2 over equals 7. Now we already have common denominators. 5x minus 10 over x minus 2 equals 7. And we can cross multiply from here to solve and get x minus 2, which will still be extraneous. Or you could have recognized that this would factor. Right? Pull out a 5, you're left with x minus 2. X minus 2 is canceled. So you get 5 equals 7. Is that a true statement? No. Since that's a false statement after your variables have canceled out, that's another way to see it's no solution. So now we're going to look at solving rational inequalities. First thing we want to do is we want to rewrite the entire equation to relate it back to 0, the entire inequality to relate it back to 0. And what we mean by relate it back to 0 is I want to know if the entire expression is less than 0 or greater than 0. So to get all your information on one side of your inequality symbol so we can look at what we're comparing it to, greater than or less than 0. From there, we're going to simplify the expression, which means factor the numerator, factor denominator, cancel what's in common. Then we got to find the critical points. We find those critical points by finding the x-intercepts, which is where the numerator equals 0, and the vertical asymptotes, which is where the denominator equals 0. From there, it's just like we did with our quadratic inequalities, or if we've done, or from our logarithmic or exponential inequalities. When you're solving, you pick a point. Once you have your critical points, pick a point from each interval that those create. And if it's a true statement, you grab that interval. And if it's a false statement, you discard that interval. We'll look at that a little more closely. But that's the idea. Get everything back to relating to 0, simplify the expression, and then find where the numerator equals 0, denominator equals 0, and then start testing your points. Give me a second and I'll get an example up here that will work together, guys. So here we have the example I want to look at. So first step was to get everything to relate back to 0. So let's move everything to the same side. It doesn't matter which one we look at or which direction we go. I like reading from left to right. So I'm just going to move the 12 over. So leave the 3x plus 1. I'm going to move the 12x squared minus 1 over and the 2. So we're just going to subtract both of those terms over to the other side of the equal sign. From there, it's just a matter of combining it all together to get a single expression. Well, we know that x squared minus 1 is just x plus 1, x minus 1. So if we're going to go through and get our common denominators, this one already has an x plus 1, so it needs an x minus 1. To give us x plus 1, x minus 1. This has x plus 1, x minus 1. This one over here needs an x squared minus 1, so it can get both of them. So that all three denominators now have x squared minus 1 for their denominator. Combine that together, we get 3x, x minus 1, minus 12, minus 2 times x squared minus 1. All over our common denominator of x squared minus 1. All that should be less than or equal to 0. Distribute, combine like terms. 3x squared minus 3x minus 12 minus 2x squared plus 2. So if I combine them, 3x squared minus 2x squared is just x squared. 3x, well, negative 3x is negative 3x. Negative 12 plus 2 is negative 10. So distribute, combine all your like terms together, and you get x squared minus 3x minus 10 over x squared minus 1 is less than or equal to 0. So that's just the relating everything back to 0, kind of cleaning it up. Now we need to find the critical points. Critical points come from the numerator, set equal to 0 and solve. So these are your critical points. The places where our function changes from positive to negative. So we solve that, just factor it out. X minus 5, x plus 2 equals 0. X minus 5 is 0, x plus 2 is 0. So x equals 5 and negative 2. Take your your denominator, set it equals 0. That's how we find our asymptotes. The other places we change from positive to negative. And if you want to factor it, you can. Or you just add 1, take square root. So x plus 1 equals 0, x minus 1 equals 0. So x equals, plus or minus 1. So we go through and I just, my brain dead. It just stopped. So we have our critical points. Now we want to see what intervals they created. So we're going to go to our number line. So negative infinity to positive infinity. Plot your critical points. So we're at negative 2, negative 1, 5, positive 1, and 5. And then we want to know which intervals satisfy this relationship, this inequality. So we pick a point from each interval, like we've done when we solve all these inequality equations. So, I don't know, negative 3, that's going to have to be negative 1.5. There's 0, that's the one we like. There's 2, there's 6. So if we go through, it's just a matter of plugging them in. So if I do negative 3 squared minus 3, negative 3, minus 10 over negative 3 squared minus 1. Go through and do all that arithmetic, and you're going to get 9 plus 9 is 18, minus 10 is 8. 9 minus 1 is 8, so 8 over 8 is 1. Is 1 less than or equal to 0? No. So we don't use this interval. That's a no. Okay, then we grab the next one. Let's try 1.5. We'll make it -3/2. So go through and do your math. 9/4 plus 9/2, which is 18/4. So 9/4, 18/4 is 27/4. 27/4 minus 40/4 is -13/4. -13/4 divided by 9/4 minus 1, which is 5/4. So what's that, -13/5? Is that less than or equal to 1? Yes. So check mark on that interval. Check the next one where the 0 is. There's the easy one. -3, 0 minus 10 over 0 squared minus 1. So -10 over -1, which is +10. So is +10 less than or equal to 0? No, it's not. So we don't get to use that interval. Go on to the next one where the 2 is. So 2 squared minus 3 times 2 minus 10. Over 2 squared minus 1. So again, it's just testing points back into that relationship. So 4 minus 6 minus 10 is -12. -12 over 4 minus 1, which is 3, is -4. Is -4 less than or equal to 0? Yes, it is. So we grab that one. And then you test the 6 out. 6 squared minus 3 times 6 minus 10 over 6 squared minus 1, 36. Minus 28 is 8. 8 over 36 minus 1, so 8 over 35. Is that less than or equal to 0? No, it's not, so we don't use that interval. So by testing a point from each interval, we see that this interval works and this interval works. Now we just need to put our brackets and parentheses on there. So remember, it's or equal to. So these values we can equal because they're x-intercepts. These values, because they're vertical asymptotes, these are x-intercepts. These are vertical asymptotes. You cannot equal a vertical asymptote. It's just a boundary line. So these have to be not equals because they're vertical asymptotes. So we have to parentheses the vertical asymptotes, and then we can bracket the x-intercepts. So that ends up being our solution. From -2 to -1, union 1 to 5. That's the solution to that inequality. So the solving part is the same solving stuff we've been doing. Get it all to one side and relate it to 0. Set numerator equal to 0, denominator equals 0, and then just test your critical points. Now, this mess right here is kind of why I like to I use a graphical technique to test. So if I was going to graphically test these points, I would still find my critical points. But I'm going to ID a couple more things, and I just erased it, so what was it? We had x squared minus 3x minus 10 over x squared minus 1 less than or equal to 0. If I was going to graph that, I've already found a bunch of the information. I found x-intercepts at -2 and +5. Found y-intercept or vertical asymptotes at 1 and -1. Y-intercept is the ratio of your constants because it's what you get when you plug in 0, so that's going to be at 10. And then your horizontal asymptote, we have equivalent degrees for numerator and denominator, so it's just the lead coefficients, the ratio of the lead coefficients. Then we go through and graph. All right, so y-intercept's in the middle with no x-intercepts, so it's going to look like that. These asymptotes only occurred once each. So we've got to be going opposite direction. Same thing here, that's on top, so that's got to be on bottom. So if I'm looking at it graphically as these intervals right here, between intercepts and asymptotes, everything that's between intercepts and asymptotes, we're asking the question, where are we, on or below? That's what less than or equal to means, on or below x-axis. Well, we can see that in this interval right here, okay, this interval right here, our curve is on or below the x-axis, as it is with this interval right here. So between -2 and -1, we're on or below the x-axis, and between 1 and 5, we're on or below the x-axis. So those are our two intervals that satisfy this relationship up here, this inequality up here. So we can do it by doing the number line analysis, nothing wrong with that. Or if you get real good at looking at the graphs, you can do a quick graphical analysis. I prefer that technique, but this will also get you there every single time. All right, that's it for solving rational equations and rational inequalities, and I will see you in class tomorrow, guys.